Yes. This is my third technical vlog. Today I thought we discussed some number data types with Java. Just started learning Java, so I thought some of this was kind of interesting. Now, when you're dealing with numbers in Java and in some other languages too, it can be a lot different than JavaScript, obviously, or Ruby or Python, in that you have to tell it which number type you want it to be, and there are multiple number types depending on uh, how long they are or how precise you want them to be. Um, so let's start out talking about that, and let's start out with the just whole numbers. Okay, now the default whole number data type is the integer. Okay, and you would write a literal um, like this: integer literal equals 1000. Okay, start off with your data type, int, short for integer, your variable name, and then the literal. Okay. All right. But these data types have ranges. Oh, man. All right. So let's see what the ranges are for integers. Okay. And we'll say, so the minimum integer value equals integer dot minimum value, and the max will be integer value equals max value. And we'll integer value okay. Let's run this. So the thing about Java, you have to run it. It's not going to automatically update or anything like that. And so here we are. So the minimum will be a negative. I think that's 2,147,483,648, and the maximum is the positive version of that same number, but you'll notice it is one less. You'll see a difference there. Okay. Now, what happens if we go over? Okay. Let's try to enter value -1. And let's take the max. We'll add 1 to it. All right. Now you'll notice that now the minimum integer value -1 gives us the maximum integer value. Okay? It's just going to roll over back to the next number in its range. Okay? So if you try to go one less than the smallest number in the integer range, it's just going to give you the maximum number. And vice versa, if you add 1 to the maximum, you'll get the smallest version. Okay? So you really kind of need to be aware of that. If you're using an integer value and it's a large number, like, you're getting in your 2 billions, you may want to think about using a different number. Okay? All right? And this is going to be the case with the first three numbers, the first three data types we're going to be discussing, especially. Okay. So, what if I need to use a bigger number than 2,147,483,648? Well, then I'd want to use the long. Okay. All right. Now the long value has its own limits. So we'll do the limits of that. Long value. I'll do long. Oh, we got a system atom. Now we've got a much longer number. Okay, you'll notice the same situation. That the maximum looks like it's like one smaller than the negative inverse of the smallest number. Okay, and again, if you try to add one or subtract one from if you try to subtract one from the smallest, you'll get the maximum. Okay, same as the integer value. All right. The third type of whole number data type we're going to discuss is the short. Okay, maybe you don't need 2 billion of something, so we'll get the short. Value. Okay. And right now, again, we're only dealing with whole numbers. Okay. These are all still integers. Now you'll notice only got 32,000 on that one. Okay. All right. Now, why would you have different data types for different lengths of numbers? Well, the short answer is memory usage. So, oh, I forgot to add one more. So what if we need something smaller than a short? What if we do byte? Okay, got another one, byte. Now we've only got 128, much smaller. So getting back to the why we would have different ones and the memory it uses. Let's see how much memory a byte takes up. Okay, a byte, number type, occupies 8 bits of memory space. Okay. Conversely, the short occupies twice that, 16 bits of memory. The integer occupies twice the short, so it's 32 bits. And you can guess what the long is. If the integer is twice the short and short is twice the byte, the long will be twice the integer. 64. Bits of memory. Okay. Now, when Java was made, computers did not have the CPU strength and certainly didn't have the memory installed that computers today have. And if you had, you could save some memory. If you're worried about how much memory you're using in a large program, by changing some of these data types, you can optimize things, and you can still do that today. But for the most part, computers have plenty of power. Your average computer has plenty of power and plenty of memory to really not worry about it. Default is integer. Okay, if you want to go to a really long integer, you may want to use the long, obviously. But as far as the short and the byte, the integer will be just fine. Okay. Now, what if I wrote out long, okay, and I'll give it a name. We'll call it long number equals, just for now, why is this giving me an error? It's saying the integer number is too large. Well, why is it saying it's an integer? I called it a log there. That's because the integer is default. And if you wanted to make it a long, add an L at the end. Okay, that's going to change that data type to the long data type. Just calling it a long here doesn't do that. You've also got to change it over here. All right. Now, just getting ourselves into that, letting you know that. That's going to show up even more a little bit later on. What if I wanted to value equals my value divided by 2. Well, that's wrong too. Why? Once again, required type byte, but provided an integer. So I could do it this way. I could add a B at the end of them. Okay. And you'll notice it's perfectly fine now. It's okay with that. All right. If I hit run. Okay. Shouldn't have any problems. Okay. But what it's actually doing, if I want that to come out as a byte, what I need to do is what's called casting. I need to tell it this needs to be bytes. Dealing with bytes. Okay, everything in here needs to be bytes. And add parentheses and byte before the equation. Okay. And now we get the run it one more time. Now we get negative 64. Okay. So without adding the byte before it, take that away. I'm going to get an error. Let's try it again. Incompatible types, possibly. Okay. Integer, because it's saying that the minimum byte value is an integer because it's written as a variable. Now I could go put a B there. I think I could do that and take care of it. Nope. Doesn't like that. Got to go and add that on that side, and that'll fix it. Okay. Next thing I'd like to talk to you about is decimals. Okay. The thing about a decimal, we call them floats. Okay. And so a single, and there's floats and there's doubles. Okay. And all this has to do with precision. If you're trying to do math and you want it to be as precise as possible, okay, you're going to use floats. You're going to use floats and doubles. All right. So what if I decided to, 5 divided by 2. Now, we know that the answer should be 2.5, right? 2.5. But it just gives us 2. Truncates the 0.5 because we're dealing with integers. It's staying as an integer, and so it's only going to give us the integer numbers. Okay? All right? Well, what if I say 0.0? Will that change it? Let's see. I know in some languages, if you put see, now I have 2 floats, and by adding 0.0, it says, oh, these must be floats, and we're going to give you 2.5. All right. Now, the first type of float is a single position precision is called a float. Okay, and a float, again, we're going to talk about memory. All right. Okay, so the single precision or the float, pardon my typing, occupies, let's see here, 32 bits of memory. Okay, and so the double, okay, occupies twice that, so 64 bits of memory. Okay, now the ranges of these are different, and I'm going to show you the ranges. Okay, so let's do this float. Okay, for the single precision, minimum float equals float dot minimum value float maximum float value equals dot maximum value float value alright, then we'll just go ahead and do this for the double equals dot minimum value value maximum double value. Let's see what these two sets of minimum and maximum values are. Okay, so the first one, the minimum of the float, is 1.4 to the negative 45th. Okay, and the highest would go is 3.4 to the, and you can see the end there. The double goes 4.9 to the negative 324th and goes as high as that. Okay. Now, what happens if, getting back to now, what happens if we want to, let's do something simple. So let's take a number. Okay, I'm going to create a new method for this just to make things a little easier. Okay, create a new method, public static void. Okay, we're just going to call it subtract decimals. Okay, we're going to give it, we're just going to say double, two doubles. double 1 and double 2. Okay. Got to give them what they are. Add that at the end. Okay. I'm just gonna go D1, D2. Okay. All right, so let's go back up into main. And let's do subtract decimals. And we're going to give it the first D1, we'll make it 0.8. Okay. And then the second one, we'll just make it easy, 0.1. Okay, we know the answer should be 0.8 minus 0.1 should be 0.7. Okay. What's up with that? It is not 0.7. It's 0.7 with a extra 1 at the end. So we've got an issue. So double is the default decimal value. So if you do a point anything, it's automatically going to make it a double. This doesn't matter at all. Okay, it's automatically going to make it a double because most of the time you're going to be dealing with doubles. Okay, but when you go and add and subtract them, you get weird answers. Okay, and that creates real problems, especially if you're trying to figure out the tax of something or doing any other accounting or precise mathematics. So when we're dealing with that, we don't typically use double or float. Okay. All right, we're going to use something else. I'm going to come in here, go up very top, and I'm going to import java.math.bigdecimal. Okay, so that's what we're going to talk about, big decimal here. Okay, so how are we going to fix this problem? Big decimal is a library, is a math library. Okay, it's a sub library of the math library within Java. Okay, and you work with it differently. Okay. So let's try it. Okay, so now we're going to say big decimal. Okay, BD1 equals new. All right, because it's like a new instance of the big decimal class. Okay. All right. And so it's going to be big decimal, and then we're going to enter in our first argument there. Okay. We'll do the same for the other argument. And then equals BD1 dot subtract. Because we are in the big decimal class, okay, we can't simply use regular operators, and we have to use the operators that are in the big decimal class. Okay, since you have dot subtract, you got dot add, multiply, divide. Okay, so let's subtract. Okay, and then we'll add This is a method inside the big decimal class. Okay. Decimal 2. All right. And let's 83. Let's see what we get. Well, it's more accurate, that's for sure. But it doesn't help very much, does it? Still not getting what we want. And there's a really good reason for it. Okay? Okay? When we do this, big decimal actually makes these values into strings. Okay? And when it does that, it changes how the methods work. Okay? So, in order to get it right, I'm going to add change these variables a bit. Okay. In order to get it right, we're going to get rid of the new. All right. And we're going to go dot value of. Okay. Value of. Okay, because reading those as strings is saying we really want the value of those strings. So, all right. Now, let's try that out. Oh, where did I miss that? Oh, right there. I had a statement. Oh, I see what I did. Got to change it there. This was giving me that. Aha! We have now fixed it. Okay? By using the value of within the big decimal, we're now getting the correct answer. All right? So that's kind of how you would work that. Okay, that's a brief, very short overview of number data types within Java. And I hope you learned a little bit from that. I know I did. All right, thank you. Bye-bye.